All right, now I'm gonna kind of go a little bit quicker on this one, all right? And I'm gonna assume that you guys already know some stuff to go through this. So to solve this problem, ladies and gentlemen, there's a couple things we need to remember. First of all, it's telling us to add, right? Well, if you guys remember, when we went back to polynomials, when we're adding, we can only add that have like terms, right? That means they have to have the same bases, which we're dealing with. Well, are these anywhat like each other? No, they don't look anything like, right? We have all these different numbers under a radical. We have all these numbers in front, so we don't have like terms. So the only thing that we learned on this worksheet is we can simplify our radicals though. So that's what I'm going to want to do. I'm going to say, all right, how can I simplify my radicals? And what I'm going to do is I'm going to want to rewrite each one of these radicals as a multiple of one of its largest square factors. So I look at number 24. Remember, you think about your square numbers. Your square numbers are square root of 4, square root of 9, square root of 16, and square root of 25 are the numbers that we're going to be using. So I look at this. What is the largest square number that I can rewrite as a product to give me 24?
4.
And that's 4. So I can rewrite this as 2 times radical 4 times 6 plus 5. What's the largest radical number, or what's the largest square number I could write for as a product for 27? 9 times 3, because 9 is a square number, right? 25, 16, or 4, none of those go into 7. Minus radical 6. All right? So now we simplify these. Well, you guys, you can take the root of 4. You can't take the root of 6. So I get 2 times 2 times radical 6 plus 5. The square root of 9 is 3. 3 minus radical 6. Okay, when I say the root, the radical, the square root, all dealing with the exact same process. Here I can multiply, so I get 4 square root of 6 plus 15 square root of 3 minus square root of 6. Now, does anybody see some like terms here that it might be able to do with this?
3. Oh, wait.
Radical 6?
Yeah, the radical 6. And one way, guys, if you're not seeing this, we can rewrite these. Think of these as like x's and y's. That's how we're going to use our operations. Okay, so it'd just be like, what if I gave you a problem like this? I said, simplify this. We'd say, oh, that's easy. It's 4x minus x, right? Because you can only subtract the 4x from an x. You can't do anything with y. So your final answer here would be 3x plus 15, right?
Mm-hmm.
Well, we're not dealing with x's and y's. We're dealing with the roots, but it's going to be the same thing. 4 times radical 6 minus a radical 6 is going to give me a 3 radical 6, plus I can't do anything with that root 3, so it's going to leave it there.
Okay.
There's my answer. All right?